Okay. Hello, everyone. My name is Ian McLaughlin, and I recently wrapped up my PhD in neuroscience at the University of Pennsylvania. And, well, my daughter can officially walk. I wouldn't call her a pro, but she went from crawling to walking to verging on running in the space of like a week and a half. And we didn't really realize that we were going to have to move from our like tiny one-bedroom apartment so soon. But so if you hear any yelps, it may very well be my daughter colliding with some of her toys because she's like bouncing off the walls all of a sudden out of nowhere because she's gone from like standing and wobbling to nearly running now in like 2 weeks. There's kind of a lot going on in biomedical science right now. Probably the most overt story you've encountered has to do with the novel coronavirus, recently named COVID-19. This naming scheme, by the way, actually departs from past coronavirus outbreaks like SARS and MERS because the WHO didn't want to contribute to the association of this particular virus with a particular country, which frankly does make some sense. And so I did talk about some of the early evaluations of this virus a few weeks ago, but given how it's spreading and the recent reporting on how it's spread, I honestly don't feel like I'm in the best position to discuss this like competently enough at this stage. So, I just suggest if you're interested in following that story, instead of looking to people in, like political positions for information, that you look to sources of information that aren't associated with any political interests. One resource that tends to do pretty scrupulous reporting on biomedical news is STAT News, STAT News, which focuses on health and biomedical science related news. And of course, the CDC here in the US has some, recommendations for best practices. Basically, the short story is just wash your hands when you get home. First thing you do, wash your hands. That's good just in general to do. So what I'll say is that I'm keeping my eyes and ears open to how this thing is spreading, and I'm washing my hands very regularly, particularly when I visit a public area, like when I go to the lab or, particularly since I work in a sort of biomedical area near a lot of hospitals. When it comes to washing your hands, you want to make sure that you include your thumbs and the areas between your fingers. I haven't been particularly satisfied by comparisons to things like the flu or the common cold because I'm just not entirely confident in the data on which those comparisons are based, at least not yet. So with that said, there's a pretty wild story that came out recently that piqued my interest. And so, in fact, I'd been paying extra attention to the coronavirus situation when applying to jobs. And so this totally like missed my radar. But I went to a lab meeting and our manager brought up this wild story of someone consuming hundreds of times more than the typical dose of LSD. And not only had they consumed that much, they'd snorted that much. And so if you're at all familiar with LSD, often referred to as acid, you might be thinking, wait a second, no one snorts LSD. That's just like not a drug you snort. And you'd be correct for a very good reason too. So LSD, or lysergic acid diethylamide, is a psychedelic hallucinogen that's active at the microgram level. So typically around 100 or so micrograms. And that's microgram, which, to give you a sense of just how little that is, it's 10 to the negative 6 of a gram. And so here's how that math works out with the metric comparisons for those of us who aren't as familiar with the metric system as, much of the world is. And so in science, we pretty much exclusively use the metric system, mostly because conversions between different weights of substances or volumes of liquids is just much easier to do with the metric system. And in neuropharmacology, we tend to work with, pretty low doses of drugs. And that's also true in medicine. If you take a medication, it's probably dosed in milligrams. Some are higher, there's a few that are dosed in grams, in fact. And of course, some that are lower, but that's the metric system, and that's generally the neighborhood. All of this to say, this is a truly minuscule amount compared to a gram. And so given how minuscule 100 micrograms is, LSD is classically ingested using blotting paper or blotters, which is just a kind of paper that happens to absorb like quite a bit of liquid. And they tend to look something like this right there. And so, why would that be used to administer a drug? Why would a paper be used to administer a drug? Well, since so little LSD is needed to induce a pharmacological effect, a pretty substantial alteration of consciousness, it can literally just be dropped using a dropper that looks sort of like this onto some paper. And so, in other words, there's typically enough LSD in a single drop of water, or maybe two, for someone to experience full-blown psychedelic effects. And if you were to let just that water evaporate, if you just like took the dropper and just put it on a table and let the water evaporate, it would basically be like an invisible amount of LSD left behind. And so, I bring up all these comparisons and examples to say that if someone were to ingest an amount of LSD that's like visible, like at all visible, it would be orders of magnitude, many, many times higher than the standard dose of LSD that people who are interested in having psychedelic hallucinogenic experiences would take. And so according to a few case studies recently published in the Journal of Studies on Alcohol and Drugs, last month it was published, that's exactly what happened. And so a 46-year-old woman who thought she was snorting cocaine, but mistakenly ingested hundreds of times more than the recreational dose of LSD, and this was back in 2015. And then, there were two other case reports in this publication. There was like a teenage girl who mistakenly drank many times more than the typical dose of LSD at a summer solstice party in the year 2000. But before going into these stories, I think it's worth noting that these are not the first examples of people taking like gargantuan doses of the psychedelic drug. But at least, these are some of the better documented ones and some of the most recent ones. And so I also think it's worth noting that there are two authors on this paper, this publication of case studies, one of whom is the executive director of MAPS in Canada. And so folks who might be familiar with the ongoing investigation of the utility of MDMA or ecstasy for the treatment of PTSD may be familiar with MAPS. And so that's the MAPS logo. And so MAPS is the Multidisciplinary Association for Psychedelic Studies. And so, these case studies weren't written up by anybody with like an overtly prohibitionist agenda or anything like that. And, frankly, I don't think the vast majority of neuroscientists these days are overtly prohibitionist regarding psychedelics. And in fact, many neuroscientists have had their own experiences. And I can understand that some folks outside the discipline may suspect as much. But given that Mark Hayden, who is one of the authors, is the executive director of MAPS in Canada, it ought to be abundantly clear that there's just no covert prohibitionist goal behind writing up these case studies. They're approaching it in good faith. And so starting with this 46-year-old woman who thought she was snorting cocaine, which of course means that she was evidently snorting LSD, she ultimately blacked out and vomited for 12 hours. And so, once again, if a person is ingesting a visible amount of powdered LSD, that's basically like an immeasurably higher dose of LSD than the standard dose. And the case report write-up notes that she'd a little bit about her sort of medical history. So she had contracted Lyme disease in her early 20s, and this was associated with sustained pain in her feet and ankles. And frankly, I was unfamiliar with the biology underlying the relationship between Lyme disease and the pain that can manifest in the feet and ankles. But I'd read that this symptom has been observed in folks who've contracted the disease. And so in particular, arthritis in the knees, ankles, and less frequently in the feet and like the small bones of the feet. And so this woman had been prescribed morphine to manage her pain, her chronic pain, and she'd be taking 4 to 6 10-milligram tablets every day and sometimes 8. And so basically a daily dose range of around 40 to 80 milligrams of morphine. And so, in other words, like she'd inevitably would have had developed like a tolerance to opioids, but not anything like the kind of tolerance that one would develop of someone who's like injecting fentanyl or oxycodone or taking oxycodone on a regular basis. So, there's a tolerance there, but it's not like massive. Okay, so in 2015, so quoting the case study, quote, she took 55 milligrams intranasally of what she believed was cocaine, but was actually pure LSD in powder form. This was the equivalent of 550 times the normal recreational dose of 100 micrograms. So, in other words, she snorted a bit of what she thought was cocaine, but turned out to actually be LSD. And so, I've seen a bunch of articles in the popular press cite this 550 times the normal dose of LSD figure. And, it's clearly directly from the write-up of this case study, which is, totally respectable and precisely what any responsible journalist ought to do. And so, I have no criticism of them for that. But I'll be honest that, I had a lot of questions when I read this part of the case report. So, first of all, people who are snorting cocaine aren't exactly, known for being, entirely precise with their dosing, right? It's not like it's, standard for somebody to, bust out a milligram scale to measure out their cocaine before snorting it, right? It's usually pretty qualitative. And so, it could be the case that this person was doing exactly that. And so my speculation is purely that. It's just speculation. But in my mind, what seems more likely is that a sort of eyeballed amount of the presumed cocaine that was actually LSD was measured out. And so, we really can't be sure, at least in my mind, that it was precisely 55 milligrams. And okay, why does that matter? Who cares? once again, the standard dose of LSD is like 100 micrograms. And so, even a minuscule amount more in powder form of LSD equates to many, many times more than the standard dose. And so, another question in my mind is like just how likely it was that it was truly powdered LSD, right? Or, perhaps it was like a pharmacologically inert powder, like flour or sugar, or, whatever, powdered milk or something, that which had been doped with LSD. So like one way that people consume LSD instead of onto like the blotter paper that you're seeing there is that it's dropped onto a sugar cube. And it's the same ultimate dose of like the active ingredient of LSD, but obviously, sugar is different. It looks very different from blotter paper. So in fact, there is a pretty amusing interview of Trey Parker and Matt Stone, who are the creators of South Park, where they say that they took LSD using sugar cubes before the Oscars. So they used sugar cubes, where Trey Parker had been nominated for Blame Canada, which was a song that was in like the South Park movie. That was basically like a cartoon musical. It's a pretty funny movie. And so, there's a lot more to that interview, by the way, and it's like totally worth checking out because it's just on YouTube. But they had worn dresses to the Oscars and were interviewed and everything like on the red carpet or whatever. And anyways, like they tell a story about having taken LSD and sugar cubes. And, I just figured I'd bring this up because I'm sure it's faded from most people's memories or most people probably didn't even know that they did this. And I think it's kind of funny. But all this to say, that sugar cubes are one of the sort of standard alternative delivery systems that are, somewhat regularly used. And while it's, of course, possible that this person had somehow, was somehow exposed to pure powdered LSD, I just have to like scrutinize how confident we ought to be in the whole like 550 times the normal recreational dosage thing. And so like, okay, why does any of that matter? So, the case study goes on to describe her experiences following such a gigantic dose. Even if it was like less than 550 times the standard dose, that still would be a gigantic dose. And that they go into the nature of her experience is super interesting and valuable. And, regardless of how confident we ought to be in like the specific dose that they cite. Okay, so what happened? Well, I can take this off. After 15 minutes, she realized something was wrong. And, I have to say, like, this caused me to ask more questions about the situation. But since it's pure speculation, we'll move on. Like 15 minutes, cocaine versus LSD, it took you 15 minutes. Anyways, she called her roommate for help. Okay, and quoting the article, quote, he noticed that the bottle of LSD had been moved and weighed the remaining powder to determine approximately how much she ingested. Okay, so that's what her roommate did in response to her calls for help. She started vomiting within an hour and continued frequently vomiting for the subsequent 12 hours. And she also noted that, in the case study quotes her here, she blacked out for the first 12 hours. And after those 12 hours, she regained the ability to communicate, after which she felt rather good for the subsequent 12 hours with less frequent vomiting, which I'm sure added to her feeling a lot better, right? So what did her roommate say about what she looked like? Like that was her own personal retelling. So her roommate said that she was mostly sitting still in a chair with her eyes either open, closed, or rolled back. And he also said that she frothed at the mouth and uttered random words and vomited frequently. He said that 10 hours later, she could converse and seemed fairly coherent. Okay, so before we get to what's, the most surprising part of this case study and probably why they decided to write it up, I think I ought to acknowledge that, while reading this case study, there was another point in the story that just made me like ask questions. So the case study notes that there was a bottle of LSD in the house, wherever they lived, and that the person had intended to ingest cocaine. Again, this is pure speculation, but I have to wonder if this exposure wasn't the first time that this person had taken LSD. And, why would that potentially matter? Well, I have to assume that there'd be a pretty big difference between somebody who'd never been exposed to LSD, or any other psychedelic for that matter, or any other, consciousness altering drug, and, someone who has at least some experience when it comes to, at least, several hundred times the typical dose of the drug. And by the way, like, if you haven't seen it, the theoretical physicist Brian Greene recounts an experience that he had taking a substantial dose of psychedelic mushrooms in Amsterdam for the first time on Joe Rogan's podcast. And he had a hell of a time. It's a pretty funny story. And he indicates what he had taken, or that he had taken, what he had taken had been marked as like the most potent dose at the cafe at which he had obtained the mushrooms, and he had very clearly what was a bad trip. And so all this to say that the case study doesn't mention whether this 46-year-old woman in the case study had past experience with LSD, and I just feel like that might be a little bit meaningful in terms of how we interpret like her experience, the severity of her experience, and the other stuff in the case study. And so, okay, so let's get to the most intriguing part of the case study. So as a review, right, this woman had been taking morphine daily to manage the ankle and foot pain that had been associated with Lyme disease. And she noticed that her foot pain seemed to abate the day after this massive dose of LSD. And she ended up stopping using morphine to manage the pain for 5 days. And perhaps equally intriguing, she didn't note any withdrawal symptoms following the discontinuation of morphine use. And so, I think it is worth noting for anybody that's not familiar that opioid withdrawal is one of the most severe withdrawal syndromes of habit-forming drugs that people can experience. It may very well be that the severity of withdrawal from opioids may vary between individuals, due to like unique genetic predispositions, as does seem to be the case when it comes to withdrawal from nicotine. Different people experience greater or lesser severity of withdrawal symptoms from nicotine. But, so this is clearly a very interesting part of the story. And I bring that up just because, we can't be 100% sure that she, had she like stopped taking morphine, that she would have had, profoundly severe withdrawal symptoms. Maybe she's just one of the people that doesn't experience particularly severe withdrawal. But, that's, again, pure speculation. Okay, but her pain did ultimately return. And she resumed using morphine to manage it, just at a lower dose than she had been taking previously. And another interesting part of this story is that she started microdosing, meaning taking small fractions of the typical doses of a drug, which are typically psychedelics. That's typically the class of drugs that people are referring to when they're talking about microdosing. And so they take, fractions of the drugs relative to those that are usually taken by people who are seeking psychedelic hallucinogenic experiences. And so, microdosing is a whole new topic that is totally worth discussing, but suffice it to say that there's a bit of a subculture surrounding the use of, this family of like psychedelic drugs at comparatively low doses for what are intended to be like useful effects that are completely independent from the hallucinogenic effects that they can produce. Okay, so she started microdosing with 25 micrograms of LSD every 3 days. So not every day, every 3 days. And, just to review, this overdose experience occurred in 2015. Well, in 2018, so 3 years later, while she'd continued microdosing with LSD, she ended up stopping the use of morphine and other painkillers altogether. She did note, however, that she had increased anxiety, depression, and social withdrawal following cessation of morphine use. Okay, so that was her story. So the case study, or the paper, also includes 2 other case studies, one of whom is a teenage female who'd taken quite a bit more than the dose of LSD that's typically consumed in pursuit of psychedelic effects. And, to be honest, like, I'm uncomfortable discussing this case report because, they do a good job of highlighting a lot of the relevant psychiatric history of this person. I just don't think there's nearly enough, recognition of the potential variables that can be addressed to engage the conclusions at which they arrive. They make some sort of psychiatric, they arrive at some sort of psychiatric conclusions regarding the potential utility of LSD. And I also think it's worth noting that it doesn't seem like this publication included any actual chemistry that verified that it was indeed LSD that was ingested by these folks. And so, I only say that because there are many other compounds that can induce LSD-like effects that aren't necessarily LSD. And, particularly at that massive dose, it's almost impossible. It's going to be impossible to distinguish, this was definitely LSD and not something else, because, these effects can be quite similar. And so, different compounds can produce similar effects, but they don't all necessarily have the same biological effects, particularly peripherally. And so, in defense of this publication, they do note this limitation of the case studies, but it is kind of meaningful because, in 2015, there are today many extremely potent psychoactive compounds that can induce effects, again, resembling those of LSD. And so, we're basically relying on the word of the roommate that they had a bottle of LSD powder. And, I'm just not convinced that it couldn't be something like one of the psychedelic phenethylamines, like 2CB, or given that they have that the effects lasted for so long, longer than 12 hours, even like a substituted amphetamine like DOI. And of course, given that she evidently sustained the use of the purported LSD via microdosing, perhaps she did have it tested. There are test kits that are available that can distinguish these compounds, and they're available at a pretty minimal cost. They're not that expensive. Okay, so with all that said, I think it's worth noting that this isn't the first publication that recounts massive doses of LSD. So in 1974, Burner, I believe is how you'd pronounce that name, and Becker, so 3 authors, wrote about 8 people who were seen within 15 minutes of snorting large doses of LSD, 4 women and 4 men. So in other words, pretty comparable to the story from the case study that was recently published that we just talked about. Funny enough, they also thought that they were going to be snorting cocaine. They also started vomiting and experienced anxiety, restlessness, and weird tingly feelings, like sensory feelings called paresthesias. And so this study did some like kind of old school toxicological assessments, like evaluating the appearance of how extracted blood clotted. It's a thing that blood can do. It can clot and, things like that. And they noted that they all had coagulopathy, which is essentially the inability to form firm blood clots. And so this you might be like, why on earth would they even think about blood clots? And it actually does make sense because serotonin signaling was already known even at that time to be involved in the formation of clots. And so after being admitted to the hospital, some were described as comatose, while the rest were extremely hyperactive with, quote, severe visual and auditory hallucinations. I can imagine. And in addition, quote, most did not remember being brought to the hospital. Otherwise, no apparent psychologic or physical ill effects were noted. A year of follow-up examinations of 5 patients. Most of the patients continue to use LSD intermittently, which I think is kind of a funny thing to note in the study. And there are other case studies of people who had been exposed to overdoses of LSD, including one that I'd never seen in 1992 involving an extremely, extremely young human. And infamously, there was a test of LSD involving an elephant that was done in the early 60s. And, I'd heard about this. I'm sure many people have, but I hadn't actually read the study until yesterday, and it is quite strange. And given that we're talking about, a massive overdose in a human, I thought it might just be interesting to review this oddity of history. And so here's how the study opens. Quote, because of his remarkable intelligence, his extended lifespan, his capacity for highly organized group relationships, and his extraordinary psychobiology in general, the elephant is an animal of great interest to the zoologist and the comparative psychologist. I just feel like that's a hell of an opening sentence. Okay, and so in this study, they also go into this thing that I honestly had zero idea that elephants did. Maybe I'm alone when it comes to that, but they do this thing called going on must. And must is spelled M-U-S-T-H. And basically that's where male elephants get like aggressive and wild and like randomly attack other elephants or people. And this correlates with a huge increase in testosterone levels and like a change of their endocrine system. And so here's a part of that study from the early 60s on this. Quote, the male elephant's periodic madness is an almost unique phenomenon in nature, and it provides an interesting opportunity for psychiatric research. What is the mysterious fluid excreted by the temporal gland during must? Does a simultaneous internal secretion intoxicate the animal? Or is the elephant's glandular disturbance merely a reflection of a more profound inner periodic hormonal thunderstorm, which also disrupts his brain and behavior? I love the writing and studies from back then. And so I neglected to mention that they also evidently secrete a kind of like gooey substance from a gland that's between their like trunk and their ear during must. I had no idea that this happened, and you can find pictures of it. It's pretty gross, but yeah, pretty wild. Anyway, so this group in the early 60s decided to induce a behavioral aberration that might resemble the phenomenon of going on must. And so the elephant was named Tusco, which is a pretty adorable name. Evidently, it's kind of a common name. And he lived in the Lincoln Park Zoo in Oklahoma City. So they used LSD because it was considered to be a psychotomimetic, which is a term that was more regularly used at the time than it is today. And it basically just means like a drug that induces the effects that sort of resemble psychosis. It induces psychosis. And so they infused 297 milligrams of LSD intramuscularly into the elephant in 5 milliliters of water. And why it wasn't saline is interesting. You know, like if you inject a human with water, you don't want to ever inject just like water into a human. It usually do saline. But, maybe just, injections into elephants don't use saline because they're just so gigantic that a salt imbalance is never really a concern. The salt imbalance is the concern when you're injecting any kind of fluid into a human, which is why you would use saline and not just pure water. And, I'm not an elephant scientist, so I don't know. But their intention was to deliver a dose of LSD that in a human would be considered a considerable overdose. Okay, so on the morning of August 2nd, 1962, Tusco was infused with 1.5 million units of an antibiotic. And so they describe how this injection was done, which is pretty intense. So the medication was injected into the gluteal muscle by a cartridge syringe fired from a rifle powered by compressed CO2. So I suppose we can all be thankful that we don't need to get our vaccines via rifle. But anyway, so the next morning, on the morning of August 3rd, Tusco was administered the LSD. And so, quote, Tusco began trumpeting and rushing around the pen, a reaction not unlike the one he had shown the day before. So they're referencing the antibiotic injection. And here's a newspaper article from the time. And then, quote, however, this time his restlessness appeared to increase for 3 minutes after the injection. Then he stopped running and showed signs of marked incoordination. Okay, that's the end of the quote. So at this point, it's getting a little bit disturbing, but the introduction of his mate kind of made me cringe a little bit extra. Quote, his mate, Judy, a 15-year-old female, approached him and appeared to attempt to support him. He began to sway, his hindquarters buckled, and it became increasingly difficult for him to maintain himself upright. And so anyways, that's kind of sad, kind of a sad image. And so I feel like this episode in history deserves its own scrutiny because there seem to have been some odd choices of drug treatments that might have been based on misconceptions of psychosis and how closely LSD mimics psychosis, and therefore how you would treat LSD-induced psychosis versus typical psychosis. But it's just worth mentioning that LSD was not the only drug that was administered to the elephant. And the elephant ended up dying, but it's just unclear. I think for a long time it was speculated that it was the LSD that killed the elephant, but there were several other drugs that were also administered that very easily could have been the culprit. But anyway, so these case studies that I talked about in the recent publication were the most recent, and they made a fairly big splash in the popular press. And, honestly, I have to appreciate that some of the popular press articles avoided including the finding that there was this reduced pain and reduced reliance on opioid painkillers because, there really, at least from my perspective, there were insufficient controls to warrant publicizing that potential effect. But it is definitely an interesting possibility that LSD might present this kind of utility, but one that really needs to be evaluated using randomized controlled trials in humans. And of course, microdosing is a totally different subject entirely, which also warrants a more rigorous assessment before anybody ought to consider it as being a reliable strategy to pursue any particular goal, increased productivity, improved mood, and so on. Also, I just because I think it's such a fun book to read and a super interesting component of United States history, and there's a significant role played by LSD itself in a book written by Stephen Kinzer called Poisoner in Chief. That's what it looks like. And I know I've brought up this book several times in the past, and to be clear, I have zero connection with this book or the author or whatever. I just think it's a super fascinating read about a pursuit of basically a mind control mechanism by the intelligence community, and LSD plays a prominent role in that pursuit. Okay, anyways, that's what I have for you today. It's a pretty wild story. I recommend you check it out. There's a lot of good articles on it. That's what I have for you today. So let's go ahead and start the live half. Okay, let's do this. Boom. And boom. Hello, everyone. My name is Ian McLaughlin, and I recently finished my PhD at the University of Pennsylvania. Oh, I have something to show you guys, finally. Hey, what's going on? Oh, here we go. And, of course, the sound is almost certainly going to be on. Yes, it is. Okay. So, check it out, guys. Check it. I finally got it in the mail. That's my diploma. let's see, maybe this is easier to see. Yeah, it's basically completely indecipherable because it's in Latin. And it oddly doesn't say neuroscience anywhere on it, but I got that. Also, I got my printed and bound dissertation. Is that upside down? It's not. Wow, shocking. Okay, so yeah. I pity anybody who would even try to get through this. You'd need like a machete, a scalpel. You need provisions. It would be like probably a form of torture that I wouldn't recommend to anybody. But yeah, there they are. They exist. They exist in the physical world. Okay. Let's see. Oh, thank you so much. Thank you. Oh, thanks, Othman. It arrived. Yeah, finally, Rob from Oakville. Morning from here. Afternoon from there. Afternoon from here, from Philly. Are you on here early this week? Am I? No, I think it's actually kind of a little bit late. Thank you so much, Cheryl. Thank you, Brad Pitless. Baby must be out for a walk. Yeah, so the baby is out for a walk. Okay, so how is tinnitus connected to the brain? Great topic. For anybody that's not familiar, tinnitus is a condition wherein there is a persistent, very, very high-pitched ringing. I think it's always high-pitched. I suppose it doesn't have to be. Excuse me. But yeah, so there are different ways that tinnitus can come about. The sort of probably the most classic way or the most common way is following damage to they're called hair cells that essentially are the things that enable us to hear things. So basically you can think of them as kind of like little blades of grass. If you watch like wind blowing over blades of grass, you'll see them sort of like vibrate or oscillate. That's kind of what happens to hair cells in our ear as different tones are amplified by some small bones inside of our ear. And the hair cells are sort of arranged almost like if you were to take a keyboard, and then curl it up, like roll it up into like a Cinnabon or something. And so different hair cells correspond to different frequencies of vibrations. And that's how you can tell the difference between a C note and a G note. Or, that's how you can tell that I'm speaking lower and now I'm speaking higher. And so there's two features of these hair cells that are unfortunate and render us vulnerable to developing tinnitus. The first is that they are quite fragile, and if a sound has a high enough volume, they can vibrate the hair cells such that they then break. The second unfortunate feature of these types of cells is that they do not regenerate. So once they're gone, they're gone. And in some cases, what can happen once one of those hair cells breaks is the brain registers that breakage, and therefore the disruption of that hair cells sending signals to the brain as just a persistent activation, right? So it's like you broke it off and you broke it off in on mode. And so as a result, that hair cell is just like constantly telling the brain, I'm being vibrated. And as a result, you hear the frequency that corresponds to the hair cell that broke. Look who's back. Okay. So, and unfortunately there are no cures today for hearing loss associated with the destruction of these hair cells, but there is a lot of, and most treatments are like palliative and just like reduce the severity associated with tinnitus. But there is a lot of research emerging from the regenerative medicine field where basically it might be possible to rejuvenate or compensate for the loss of these hair cells through the use of something like stem cells, where you just essentially regrow the hair cells, externally or just using these stem cells to replace them. But as of yet, I'm not familiar with any treatment that's available. Okay, let's see. First thing, I asked my professors here, show me a link to your PhD, and they're always happy answering. Yes, indeed. Yeah. So I just showed my diploma. That's in case anybody's interested. Are the hair cells in the ear canal? So not quite. So they're further inside the head, I guess is how you can think of it anatomically, and they're curled up in the cochlea. It's the first time you've heard of that. Yeah. And it's, tinnitus can be extremely, not debilitating, but extremely it can affect your life pretty severely. And in some cases it can be more severe than others. And oftentimes people who work around like very loud machinery or around, who do like, marksmanship using rifles or whatever, guns, construction equipment, landscaping equipment, and on, those folks tend to be more vulnerable, not only to the hearing loss, but then potentially also tinnitus. What's also interesting, and I'm actually not familiar with the pharmacology here, there are some drugs that can induce tinnitus. And I don't think that the tinnitus is actually permanent, but I could be wrong about that. But anyways, yeah, the sort of the standard pathway by which people develop tinnitus is through being exposed to loud sound chronically. How to improve confidence? That's probably a question that's better suited for somebody in psychology, or perhaps has experience with kind of coaching or self-help or that kind of thing. I don't have I guess I could go through a couple ways that a neuropharmacologist might try to solve that problem. So the first is that there are clearly drugs that can induce elevated confidence, irrationally elevated confidence. This is sort of one of the classic effects of the psychomotor stimulants like amphetamine, methamphetamine, methylphenidate, cocaine, and indicating that perhaps, at least to some degree, the catecholamine neurotransmitters, dopamine, norepinephrine, must play some kind of role in regulating confidence, perceived social status, that kind of thing. And so as a result, if you were to say, like, if you can increase the confidence of somebody for a period of time, and I'll give you $10 million, I would administer them amphetamine or cocaine. But of course, that's not a sustainable approach to improving your confidence. Another way is, I believe in both males and females, elevated testosterone will elevate confidence. But again, for similar reasons, that's not a particularly sustainable approach to elevating confidence. And so here's what I do. I don't do either of those things. What I decided is that I wanted to get really, really good and base my confidence on my ability to get good at a specific thing, and invest a lot of my emotional energy and sense of accomplishment on my ability to accomplish, to excel in that field. Of course, I selected neuroscience as the field, but my suspicion is that if you can base your confidence in something over which you have some control, rather than what you look like or where you come from or who your family is, I suspect that might be a healthier, not necessarily surefire, but healthier way to try to elevate confidence. Do you study the subconscious mind? Yes, I do. I don't, that's not the goal. It's not like the prime directive of my research was to study the subconscious. I just happen to study parts of the brain that would fall under the sort of purview within the neighborhood of the subconscious. And generally speaking, folks who study some of the more evolutionarily ancient parts of the brain, meaning more primitive, not meaning worse, but just that they've been in a brain of some animal for a longer period of time than some of the fancier new parts of the brain, like the frontal lobes, the neocortex. Generally speaking, these older brain regions tend to be more associated with the subconscious than the sort of conscious attention. And that's sort of, you can think of the relationship between the anatomy of the brain and the relationship between the conscious and subconscious mind as, the vast majority of the brain is associated with the subconscious. These are parts of the brain that tend to be involved in emotional regulation. I should say, parts of the brain that are typically involved in emotional regulation tend to be more associated with the subconscious. Whereas, executive planning, forecasting of future events, predicting future events, consideration of cause and effect, cost benefit, those tend to be more under the purview of conscious awareness. Your mind has nothing to do with what you look like, period. Well, first of all, yes. There's no inextricable link between, appearance and intelligence. That's you can be confident of that. But there are some interesting sociological evaluations of like the effect of perceived attractiveness on perceived intelligence. And it turns out statistically that people will presume that somebody whom they consider to be physically attractive as being more intelligent than they objectively are. It's just one of the various unfair aspects of being a primate. And And, like, here's an interesting study that was done. So there was a group of scientists, I forgot where they were, but they recorded a bunch of people dancing, okay? And they did some kind of motion tracking, computer magic to basically extract all of their movement data and then recast them as basically like stick figures, right? Where, you couldn't see anything about them that would indicate attractiveness or a lack thereof. And then they asked people to look at videos of these stick figures dancing, and they were all dancing the same style and had the same sort of level of prowess and everything. And it turned out that the people, and then they asked these people who were watching the videos to rank how good of a dancer these people were. Again, they had no recognizable features. It's just like watching stick figures dancing. And it turned out that people who were ranked as better dancers tended to also be ranked as more attractive. And so there are these like weird, attractiveness like influences how other people treat us and how you interact with other people. And so, that therefore can influence things like educational attainment, professional, progression and things like that. So it is more complicated. I went on this big tirade because I was just thinking about this yesterday. It's like the interconnectedness of existence as a Homo sapien. But yes, I agree. Your intelligence has no inextricable link to attractiveness. Are you sure you aren't artificially elevated your consciousness? Well, I guess to a certain extent, elevated consciousness elevated confidence is kind of artificial. But okay, your thoughts on prospects of bioelectromagnetic therapy to kill harmful bacteria and effect on the brain. Bioelectromagnetic. So that is such a giant combination of different potential treatment modalities that, I can't narrow in, unless you're referring to like a specific innovation or a specific medical device. I don't really know how to even begin with that. Like certainly let's say organic or biological treatment of bacterial infection. That's like what we do essentially. That is how we treat bacterial infection. Electric. I mean, I can't imagine how electricity would be particularly useful to targeting bacterial infections, but I'm not a physicist. Formally, and magnetic, that I don't, there's no feature of bacterial genetics or bacterial biology that would respond preferentially to like being exposed to magnetic fields. So yeah, I would put my money on the bio side, the bio component of that long phrase. But it could very well be the case that like there is something out there that I've just missed. Thanks for that. Looks are not what's in their mind. Indeed, I totally agree. So basically, finding the frequency that bacteria operate at and kill it by sending those frequencies. So I'm not quite sure how you're using the term frequency. The frequency just refers to the rate at which a thing happens over time, right? And so, neurons fire impulses at unique frequencies. We call those hertz, the number of events per second. And different neurons will fire at different frequencies throughout the brain. And, almost at like the bare minimum, the way that neurons encode information is in frequency. But like, it's not like, and so, there will be I assume in bacterial biology, like there are various frequencies or like, let's say biological cycles that occur, the release of certain peptides, or things like that, but it's not like there's like an overall governing frequency that could be exploited to target bacteria. And let's say you're exposing bacteria to like let's say some kind of ideal frequency of magnetic stimulation. I just can't imagine how there would be any meaningful interaction there. So yeah. So I would put more of my money in the biological approach to targeting bacteria, just because like you're engaging bacteria on as they come, right, in the language they speak in biology, and so by like, for example, targeting something that using a small molecule, targeting something that bacteria require to maintain their sort of membrane or to enable them to perform genetic, expression. So sounds like you watch too much Rick and Morty, son. I've never watched Rick and Morty, which I know makes me like a terrible millennial, but can you explain dementia? My wife has had it since your 50s. Sure. So I'm sorry to hear that. So dementia is a broad umbrella of a bunch of different diseases that can cause dementia, the most common of which being Alzheimer's disease, but there are other forms of dementia like frontotemporal dementia, Lewy body dementia. Lewy body dementia, I believe, is the form of dementia that Robin Williams, the late comedian, suffered from. But broadly speaking, the reason that many dementias, the appearance or the manifestation of many different kinds of dementias tends to be pretty consistent, pretty similar, is just because what's happening is that, like, for a lot of the faculties that we take for granted, language, memory, creativity, cognition, having ideas, those emerge from the interactions of a variety of different parts of the brain, right? And so the hippocampus, the frontal lobes, the thalamus, all need to be able to interact with one another to sustain effective communication, sustain memory. And dementia, and essentially if you disrupt any one component or multiple components of those different constellations, you will have a disruption of those capabilities that rely on large constellations of disparate brain regions that aren't like really close to each other. And so that's ultimately what it is. It's sort of like a global breakdown of the ability for different brain regions to collaborate with one another. So like Alzheimer's disease, for example, the way that we think Alzheimer's disease causes dementia is through the accumulation of two aggregates. And you can just sort of think of them as like the lint that can sort of like accumulate in your pockets, right? Sort of, different threads, different fibers in your pocket sort of break apart and then they interact with one another and they clump together. That's kind of what's going on in Alzheimer's disease, but in two different aggregates, one of which is inside of neurons, one of which is outside of neurons. Inside of neurons are called neurofibrillary tangles, and outside of neurons are called amyloid beta plaques. But fundamentally, they're really quite similar. They're sort of the byproduct of mistaken molecular interactions within neurons that then produce problematic forms of different proteins that then aggregate with one another, and over time, they can begin to disrupt neuronal functioning. But and that's just one example, but like, Lewy body dementia, frontotemporal dementia will arise from kind of similar mechanisms of disruption. Some research suggests that ankylosing spondylitis condition can lead to dementia. Thoughts? I've been meaning, like, that is one of those wild terms, and I've actually looked into it before, but it never comes up. So my memory is failing me here on the biology of that condition. Okay. Quantum theory says we are the product of frequencies, different levels of frequencies. Well, sure. And thank you so much for the super heart, Fig Media. I really appreciate it. So yeah, like, I am by no means an expert in quantum mechanics. And in fact, if you're interested in asking more about quantum mechanics, I suggest you check out two accounts. One is DC Hooper 91, and one is, of course, it's like an initialism. Actually, you know what? Go find DC Hooper 91, and in her profile, she'll include some information on her former institution that is essentially like a physics department. And they talk about physics on a regular basis, kind of like how I talk about biology, biomedical science. But like, again, like a frequency is just referring to the number of events per unit time, usually second. And so I gave you one example of a frequency in the brain, like the number of times that a neuron is firing impulses per second. Another frequency, however, can be the frequency of neurotransmitter release or the frequency of hormonal release. So it's just counting the number of events per unit time. So it's not like, there is this like the human frequency, right? We are composed of, or we contain many varieties of different frequencies. And there's nothing like metaphysically meaningful about there being frequencies. It's just a way of counting events over the course of time. And so, I've had conversations with physicists asking about, okay, like, do you think that, there are meaningful questions to be asked about the role that quantum mechanics plays in the brain? And of course, the first answer is yes, of course. Quantum mechanics underlies a lot of, physical dynamics, and it's important. If you want to understand anything, you have to understand the basics. But it's really most meaningful at the quantum scale. So at, quarks and gluons and, tiny, tiny, tiny little particles. when you're studying a larger system that operates on larger scales of physics, quantum mechanics isn't necessarily the most effective means of interrogating that physical system. So yeah, I mean, I think it's a little perilous to draw like very strict bridges between, pretty disparate domains of science, because those bridges haven't been enumerated yet. And so, there can be terminology that is used in other domains of science that resemble those of other domains of science, but that doesn't mean that they're meaningfully related. There might be something interesting there, but I also feel like, and this is me a little bit on a soapbox, that quantum mechanics sort of lends itself to a lot of the use of loose terminology to come to conclusions that the quantum physicists themselves would never come to. And this is generally done by people who are not experts in the field, but are eloquent writers or very creative. And so, like Deepak Chopra is probably the most overt example of this happening. And so, yeah. So in any case, it's just, if you're trying to understand the mind and consciousness, at least at this stage, the most productive toolbox that we have at our disposal is neuroscience, physics, biochemistry, organic chemistry, psychology, and not like, super minuscule parts of our physical universe. Okay. ¿Por qué vuelan los pájaros? So yeah, I used to have a bunch of what are they called? Sticky notes, Post-it notes, I guess, up there. And I decided so they were only up there at that point for like symbolic or like sentimental purposes. They were all for either writing my dissertation or for preparing for my defense. So I could just stand in front of a bunch of different Post-it notes and just review different ideas that I wanted to keep fresh and top of mind. I am past those stages now, and so I just collected them and put them together into a little like baggie that I'm gonna put in a box somewhere and forget about until my daughter's like 25 and she's like, my God, you actually studied this stuff. And so yeah, I'm sure they'll be replaced with something else. I find it a very useful cognitive tool. Okay, let's see. How does the mind's eye see things that haven't been witnessed by sight, like spiritualness? That's a very interesting topic. Okay, we will get to that in a second, but we have a caller. Let's see if I can... and believe me, we can get to that. So I think that your name... Oh, no, we lost the caller. That's too bad. All right. Feel free to call back in, or feel free to call in anybody else who would like to chat for a while. I have my book ready. So, okay. Visualization is essentially the thing to which you're referring. And there's a lot of interesting... kind of recent research on differences in different humans' ability to visualize things, like anaphantasia, for example, or aphantasia, I should say, is a phenomenon that it has not reached a kind of like consensus within neuroscience, but it has sparked a lot of very interesting conversations within neuroscience. Okay, more on that after this. Let's see if we can connect this time. CS Na, are you there? Can you hear me? CS Na?
Hello.
Hi. What's your name and where are you calling from? Are you there?
Hello. Can you hear me, bro?
What's your name and where are you calling from?
Can you hear me?
Yeah, I can hear you. Can you hear me?
Are you there, bro?
Okay, yeah, it sounds like we have a sound problem. Sorry about that, man. Okay, back to aphantasia. So, and this is, I'm only like going here first because it is this kind of like really interesting short story, but I think it does kind of demonstrate the differences in our conscious experiences. So, if I were to ask you, all of you lovely people, to imagine that in my hand I'm holding a butterfly, and I don't tell you anything about the butterfly, but I'm just asking you, visualize with your mind's eye that there's a butterfly in my hands. Now I'll keep my hands up here. And so now what I'd like to ask you is, on a scale of 1 to 5, 1 being there's no butterfly there at all, no visual experience whatsoever, to 5, meaning like I am literally having a visual experience of a butterfly in your hand. I can literally see it as though there was actually a butterfly in my hand. I would like to hear, give me 1 to 5. Okay, so Rob from Oakville says a 4. And I'll keep it up here, and I'll keep my eyes open. Butterfly is there. Oh, okay, great. 5. So Steph. I'm sorry, I guess I hope you'll excuse me if I call you Steph. So Steph has a 5, and now we have D Cool at 5, Sherry at 4. Okay, so these are pretty high numbers. Okay, let's see. So basically, we have like a 4.5 average, which now I'll tell you what my number is. Yeah, so Abrams Carroll 0. That wasn't an option, but your point is well taken. 0 visual experience. Now I would agree with Abrams Carroll. I have 0 visual experience whatsoever. I have no idea what people mean when they say like visualize, and I'm literally seeing it. If that were to happen to me, I would think that I was having a somebody dosed me with a hallucinogen of some sort, or I was having psychotic break and visual hallucinations. It would startle me because I've literally never been able to truly visualize something. And like, I played sports in high school, and coaches would regularly say like, visualize the play, visualize the basket, scoring the basket, visualize the end zone, visualize hitting the baseball. And in my mind, I was always like, okay, I get it. Like you're saying like, imagine what it would be like to hit the baseball. Imagine what it would be like to score a 3-pointer. So I never was like, what does that mean? But evidently some people, they literally have a visual experience of those events. Now, I have to speculate as to whether or not some of that is just a mistake in language, where people were actually having very similar experiences, but we're rating them differently because some of us are a little bit more sort of amenable to like abstract, literary, words, metaphorical. But there is some research out there that suggests that no, actually there is a consistent difference if you are rigorous about the language you use, a consistent difference in people's ability to visualize things. And so that's just one example, right? So how is it that some people can visualize things? Well, it turns out that some people truly can visualize things and some can't. And we don't know what the kind of basis for that is biologically. It'd be really interesting to study. I would love to be a part of a team that, leverage like fMRI or some kind of brain imaging during these visual tasks to see if there are just some substantial differences. And like, for example, I could imagine my hypothesis would be that in people who can visualize things like a butterfly in my hand, they might have some actual activity in their occipital lobe, in their visual cortex towards the back of their brain that's responsible for deciphering visual fields. Whereas people like me who have aphantasia, do not, that could be a very very practical or like tangible difference that would explain this difference. Or maybe there's something else, it could be like, some association cortices or whatever. But in any case, we don't know what that is. So there is that distinction in visualizing. Now, if you're saying like, how is it that I can, like in a dream, how is it that I can have experiences that I've never actually experienced in my day-to-day life? Well, I would ask you to scrutinize that a little bit further. Just how exotic are these experiences, right? You might be imagining interactions with, somebody whose face you've never seen in your life, or some person you've never met in your life, but it's still an interaction with a person. It's not like you're dreaming something that has zero relationship to the physical world. Even if you dream that you're flying, well, there are some animals that can fly and you can watch them fly. And, and so it's not altogether that exotic that you could imagine what it would be like for you to fly, right? There's still some basis in the physical world on which from which these imagined visual experiences emerge. So there's that. Another component to this, because I know you brought up spirituality in particular, is that there is a part of the brain. That's my daughter saying pasta. That's her favorite food. There's a part of the brain that is responsible for determining just how profound an experience is. It's a feeling of profundity, right? You stand in front of, the Grand Canyon, or, you stand in the Sistine Chapel, or, these just sort of like transformative or transcendent experiences, they induce a feeling of, wow, this is special. This is worth remembering. And so, there are certain drugs that can actually artificially induce that experience. Cannabis, for example, can induce that experience that, wow, everything is so profound. And, psychedelics can also induce this. And so as a result, it's just sort of like, it's one of the panoply of kind of perceptual experiences that we have is the feeling of profundity. So, if I were to, using TMS or some kind of method, if I were to magically stimulate that part of the brain when you are just sitting in your room, you would just experience like, whoa, this is such a profound moment, right? And so yeah, that I know that was like 3 somewhat disparate approaches to that topic, but I feel like there's a relationship there. That was sweet. Okay. Some S people make life S. CNN. Okay. I feel like there could be one part of the internet where we don't talk about politics. The differences between artists and non-artistic people. Wordsmitter. That's a super interesting topic. So first of all, there are studies of the different cognitive strategies that people employ to solve novel problems. And broadly speaking, you can sort of bucket these into relying upon insight, or what you might, consider to be creativity, versus relying on analysis and sort of, meticulously outlining a problem, defining the problem, and, projecting the best solution based off of your analysis of the problem. Whereas, the alternative, the creativity-based strategy is like, you don't worry about it too much. You sort of let your subconscious kind of steer the ship. And, you're taking a shower and, the solution pops into your mind. And there have been studies that suggest that there's no significant difference in how, effective either of these strategies are. And it could very well be the case that in certain conditions, one is superior than the other, but it's not like the insight-based strategy is consistently superior to the analysis-based method or vice versa. So there is that creative people may, generally speaking, rely more heavily on the creativity or insight-based cognitive strategy. We also know that people who tend to have elevated levels of anxiety will tend to bias more towards the analysis strategy. It's just, statistically, the folks who are ranked as analysis-based or rated as analysis-based tend to be also report higher levels of anxiety. So it could be that there is a kind of affective or mood-based predisposition that will push you towards one strategy or the other. Okay. Oh, and then there are also, so artists do tend to consume drugs at a higher frequency, which I don't know, take that for what you will. But it could very well be the case that artists will tend to also be more drawn to novelty and unknown circumstances, unknowns. There are sort of consistent differences in how drawn people are to unfamiliar experiences. So anyways, all of this to say, like, there are some consistent cognitive differences between people who tend to be drawn more towards insight or artistic endeavors versus more analytical. Okay. Drug interaction to self-medicate underlying anxiety, perhaps. That's totally possible. It also tends to be the case that people with higher IQs, which, I've said over and over, the IQ test is not a comprehensive analysis of human intelligence, but it is one way to analyze certain components of human intelligence. People that tend to score higher on the IQ test also tend to consume drugs at a higher frequency. So yeah, there might be some relationship there. I don't know. Okay. Thoughts on CBD. So CBD, for anybody that's not familiar, is cannabidiol. It is the sort of lesser known, up until recently, lesser known cannabinoid or active ingredient of cannabis, pot or weed or skunk or grass or wacky tobacco or okay, I'll stop. CBD does bind cannabinoid receptors, just like THC, tetrahydrocannabinol, the better known active ingredient of cannabis does, but they seem to bind distinct receptors, or largely distinct receptors. THC tends to bind more the CB1 receptor, whereas CBD tends to bind more of the CB2 receptor. THC is thought to be responsible for more of the psychoactivity of cannabis, some of the more pseudo-psychedelic effects, the mood-altering effects, whereas CBD is thought to actually influence the pharmacology of THC, but not have substantial psychoactivity of its own. So some studies have evaluated the efficacy of CBD for managing chronic pain, for managing chronic anxiety, and sleeplessness, and one of perhaps the most significant examples of its utility is in people who have treatment-resistant epilepsy. CBD, in some cases, has been shown to be able to reduce the frequency of their epilepsy. Yeah, wacky tobacco. I haven't heard that for many years at this point, but so there already is some clinical utility for CBD, but it's still being evaluated for some of the other purposes for which it's used. So my take on CBD is that it's potentially quite useful, and what's nice about cannabinoids is that they are not toxic to the nervous system like other medications can be, and the risk of overdose is not even remotely close to that of opioid painkillers. Opioid painkillers also do not damage the nervous system, but they do suppress respiration. And so an overdose of, a drug like morphine or codeine, or perhaps more relevantly, oxycodone or fentanyl, there is a much higher likelihood that somebody will die following an opioid overdose than anything like a cannabinoid overdose or cannabis overdose. My only issue with the sort of CBD conversation is that there does seem to be quite a bit of exaggeration, or at least unsubstantiated claims about how useful CBD can be for a whole wide range of maladies, and there's just no evidence to speak to its efficacy or its utility there. And so as a result, we could talk about why I think that happens, but the point being that I think that one ought to be a little bit skeptical of some of the claims that are made about CBD, relatively harmless, except for when people suggest that CBD can cure depression or PTSD. Maybe it can be helpful, but generally speaking, it's not prudent to forego, treatments that are statistically, clinically evaluated for their utility in treating something like depression, that for instead using something like CBD, which really has not been evaluated. Okay, I've tried CBD, didn't work for me. I used to smoke pot, but can't because caused panic attacks. Yeah, I mean, that's actually not particularly unusual. And there does seem to be this really intriguing age-associated component to that reaction to cannabis, that anxiety. It seems to be the case that as we get older, we're much more likely to experience severe anxiety following being exposed to cannabis than when we are, my daughter's just said bye, which is very cute. Somebody's leaving. Right. So, whereas cannabis might have been anxiolytic or it might have reduced anxiety, earlier on in life, then can actually induce anxiety and exacerbate it when we get older. And what's interesting about that is that the cannabinoid receptor system actually changes as we get old. So as we get older. And so, what happens when a cannabinoid receptor is stimulated or bound, changes as we get older. And so it could be and by the way, one of the parts of the brain in which this happens is the amygdala, which isn't necessarily the seat of anxiety in the brain, but it is involved in fear perception and anxiety. So, is anxiety caused by neurotransmitter levels? In part, yes, but I mean, essentially everything that falls under the umbrella of consciousness is influenced by neurotransmitter levels. But neurotransmitters are just one sort of character in the story of, your conscious experience. For a long time we had the serotonin hypothesis of depression, where because certain drugs that were shown to manipulate serotonin levels were shown to also be effective for, treating depression. It was then thought that, so depression must just be a chemical imbalance, right? And that's a phrase that's still used widely today, but it's really insufficient. It's not comprehensive enough to really speak to what any any product of consciousness is. Nothing, or extremely rarely is it the case that any malady, any disease, any disorder is the byproduct of a disruption in just one neurotransmitter. It's just kind of not how the brain works. Everything is going to be the byproduct of multiple neurotransmitters, and no psychiatric condition is just going to be so simple as a chemical imbalance. It's more how these neurotransmitters influence the activities of circuits of neurons. And neurotransmitters are one way by which those patterns of activity can be affected, but they're not the only way. And so yes, anxiety can arise from unique, let's say, signatures of neurotransmitter levels, but not exclusively by those levels of neurotransmitters. It's a broader story than just neurotransmitters. Some people take amphetamines for depression. Yeah, well, I'm sure they do, and particularly people who use them recreationally. A lot of recreational drug use of mind-altering substances is a byproduct of a sort of, self-medication isn't quite the right word, but a kind of inadvertent self-medication. But amphetamine is definitely not an optimal strategy to manage depression, because amphetamine, like essentially all psychomotor stimulants, is characterized by a sort of a euphoria and an increased motivation, an improvement in mood, followed by subsequently, depending upon the different drug, different time courses, but subsequently by a crash, where essentially the pendulum swung this way and you were happy and your depression or anxiety were alleviated, and then the pendulum swings the opposite direction and they're exacerbated. And then that can, and in fact this was or has been one of the kind of prevailing theories of addiction, is that the initial drug exposure is motivated by just that, by a pursuit of improved mood, of euphoria. And then because of that pendulum swinging, there is this downward spiral characterized by escalating dose, more severe swings of the pendulum, and incentivizing continued consumption of the drug. That is just one component of addiction, but yeah. So that's why there's a reason that people become addicted to opioids or psychomotor stimulants or alcohol, and that is because they are very effective at manipulating mood. That is like their prime purpose. But there's also a reason that they haven't proven to be effective treatments for depression, and that is because they're not a sustainable way to approach these parts of the brain that are implicated in depression. Can you try to get to my question on ketamine? Sure. So brain dead. Let's see where you are. Ketamine. How can I get my doctor to prescribe me ketamine without it looking like drug-seeking behavior? Well, I mean, far be it for me to advise you on how to get ketamine. But if I were interested, if I were being treated for depression and nothing was really working very well, the conversation that you should have with your physician is, hey, this isn't working. Is there anything else that we can try? And there was recently, the FDA recently approved a preparation, an intranasal preparation of a ketamine analog called S-ketamine, specifically for depression. And there's a lot of evidence at this point that ketamine is effective for treatment-resistant depression. The question isn't whether it's effective, it's why it's effective and whether or not we can improve on ketamine. But just, so you're aware, it's not like they just give you a bottle of ketamine and, leave you on your merry way. You go into a clinic, an anesthesiologist doses you with ketamine, and you stay in the clinic for the duration of effects, and then you go home and you don't go home with ketamine. But there's nothing wrong with wanting to try different things to treat depression, particularly if what you're trying right now doesn't work. That should just be the main conversation that you have. And then, you can say, listen, I'm interested in trying something other than these SSRIs or whatever it is that you're using, that you're prescribed. And then, trust your physician. Your physician's goal is to improve your depression. I know I've read a lot about it. It's actually a separate chemical than ketamine. Yeah, so it's S-ketamine. It's an analog of ketamine. It's really quite similar. Okay, my doctor prescribed me Adderall for depression because SSRIs made me more depressed. That's interesting. I mean, yeah, physicians do have a lot of leeway as to what, it's called off-label prescriptions. That isn't, I don't think most physicians would agree with that decision, but hey, who am I to question your physician's judgment? CBD replaced my antidepressant. Well, that's fabulous. I mean, I would certainly be elated if CBD turned out after, doing randomized controlled trials, randomized, patient selection, that would be thrilling if CBD were an effective antidepressant. It's just I hesitate to just make that claim because there's just not a lot of evidence that it is. LSD, yes. Oh, I forgot to mention it. So on YouTube, before I went live on Twitter, I talked about this recent study that came out. It's a publication that came out of case studies, one of which involved a person who had mistakenly or inadvertently snorted 55 milligrams? I think it was 55 milligrams of LSD, powdered LSD. And if you're not familiar, the standard dose of LSD is around 100 micrograms. So this was like 55 milligrams. And so it was in the ballpark of 550 times the sort of standard psychedelic dose of LSD. The story is a lot longer and more interesting than that. And I talked about some of the history of massive overdoses of LSD. And I also talked about this one part of the history of LSD that I think a lot of people who are, interested in LSD might be familiar with or might have heard of, but perhaps aren't familiar. And I actually had never seen this study before. I'd never read this study, but it was a study in 1962 where Tusco the elephant was administered like 257 milligrams of LSD or something. And it's a weird story. And if you go on the YouTube, you can type in like Ian, anthropoid brain or something like that. You'll find it. There's like pictures of the elephant and everything. I also talked about this. If you, Trey Parker and Matt Stone, if you're unfamiliar with them, they are the creators of South Park. And at one year at the Oscars, I think Trey Parker was nominated for Blame Canada, a song in the movie South Park. And they both, first of all, went to the Oscars in dresses, and I have a picture of that. But they also both went to the Oscars after having taken LSD that was dropped onto sugar cubes. And there's interviews of them doing this, and it's pretty funny. There's both interviews of them after the fact when they retell the story, but then there's also just interviews of them on the red carpet, and you can sort of tell something's up. Anyway, so yeah, you can check out the YouTube. I'm close to now being able to make it much easier to find my channel, but just type in like Ian Anthropoid Brain. It's a fun story. Okay. Oh, wait. Same goes for inner voice. Self-talk when you think. Some hear, some don't. Yeah, Fat Tad Rider brings up on YouTube that, yes, there's a difference in how people read. Some people, sort of narrate the reading in their mind as they read, and some people don't. And what's, I think it'd be a fascinating study to do is to see if you can take someone who says that they don't have any inner narrator when they read, and then, make them aware of that and say like, oh, really? You don't hear a voice when you read? How weird. I do. And then see if you can convert them into people who do hear a narrator. Not that there's one better than the other, but there's a guy on YouTube who drops acid and does specific things, like goes to the circus or something. Yeah, there have been a couple. Actually, there was one of the first like big internet memes, at least of my generation, was a guy who would smoke salvia divinorum, which it's not a psychedelic. We can talk about the pharmacology of salvia if you'd like. It is quite interesting. It's actually an opioid, believe it or not. And then he would do gardening and stuff like that. It was really quite amusing. And salvia, at least at the time, was legal. I believe it's only illegal in some cities at this point. But anyways, yeah. It's not the best genre in my opinion. There's also some alarming videos of people smoking salvia and really hurting themselves. But in any case, yeah, it's a weird genre of YouTube. Does the pineal gland produce DMT? Great question. I love that you just focused it right there on that topic. So here's the short answer. Yes, but not very much at all. Okay, that's a short answer. The longer answer is there have been studies that have found trace levels of DMT in the brain, okay, in homogenized extracts of different brain regions. But the key word there is trace levels. So that means that at extraordinarily, barely detectable levels, concentrations, like numbers of molecules, yes, DMT has been detected, but not even remotely close to levels that you would find of like serotonin or dopamine or glutamate or GABA, the neurotransmitters with which you might be familiar. Also, there's no reason to believe that the pineal gland, let's say the only reason to believe that the pineal gland would have some kind of, potential relevance to the detection of DMT is that it produces melatonin. And melatonin and serotonin are extremely similar molecules, and dimethyltryptamine, or DMT, is also very similar to serotonin. And so, it could be the case that there is some enzymatic pathway that will, under very specific circumstances, create dimethyltryptamine rather than, melatonin. But once again, it's never been detected at very significant levels at all in any animal. It is there, but it's there at extremely low concentrations. There's also no evidence to support the claim, the speculation that dimethyltryptamine, a massive release of that molecule, is responsible for our dreams, nor for near-death experiences. And in fact, we can explain dreams and near-death experiences without the needing there to be a psychedelic drug to induce these experiences. We can explain dreams without needing a psychedelic to explain them. So there's a lot of speculation around dimethyltryptamine. And a lot of it arises from a book that was written, I think in the 70s, called The Spirit Molecule by a person named Rick Strassman. I believe he was a PhD. But yeah, there's a lot of speculation. And there's nothing wrong with speculation, right? It's just that, unfortunately, that speculation was taken to be claims of fact or of, evidence-based claims, and they just aren't. And so there's no good reason for you to believe that dimethyltryptamine plays any significant role in consciousness whatsoever. Is most DMT synthetic then? Well, it depends on what you mean by synthetic. So dimethyltryptamine is just a molecule. You can synthesize it, using organic chemistry, but generally speaking, when people are consuming dimethyltryptamine recreationally, it's being extracted from a plant. Most frequently, at least as far as I'm aware, the Mimosa hostilis sort of vine. It has sort of higher concentrations of dimethyltryptamine and also some analogs of DMT, like 5-methoxy dimethyltryptamine, than most plants. But dimethyltryptamine is present. It's a very simple molecule, and it's present in a lot of different plants. Are you familiar with ibogaine? Yes. So, it's interesting that ibogaine has been coming up more frequently these days. So, in fact, ibogaine was the topic of the first essay I ever wrote when I decided to major in neuroscience in college. So ibogaine is a molecule, it's a drug, psychoactive drug, that is present in a tree called the Tabernanthe iboga. So this is a tree that I believe is native to West Africa, and it produces ibogaine. Ibogaine is a very interesting drug. It is a hallucinogen, and what makes it even more interesting, apart from its ability to induce hallucinations, is that it also seems to have some unique anti-addictive properties. Now, I think it's worth acknowledging that other psychedelics have been, other hallucinogens, and namely psychedelics, have been claimed to also have anti-addictive properties. So it's not like ibogaine is the only one that can do this, but it has been, for perhaps the longest period of time, been associated with anti-addictive effects. Now, and almost all of this comes from anecdotal data. So meaning the stories of people, telling their own experiences and stories. People who are addicted to methamphetamine, people who are addicted to heroin, and I believe also nicotine, reported that after, traveling outside of the United States, usually because ibogaine is as illegal as a drug can be in the United States, they had to travel to, Mexico or Costa Rica, and then they go through this sort of kind of a ritual. Then they experienced, no significant withdrawal symptoms and no significant cravings for a long period of time. The problem, or the challenge, let's say, with ibogaine is that, yes, it has this effect, but it also unfortunately induces about 48 to 72 hours of hallucinations. And so, you go to sleep, you're hallucinating, you go to sleep, you wake up, you're hallucinating, you go to sleep, you wake up, you're hallucinating. That's a long, long time. And so as a result, not everybody is interested in that kind of an experience. But even beyond ibogaine, there have been some evaluations of an analog of ibogaine called 18-methoxycoronaridine, 18-MC, which in animal models seems to also have some anti-addictive properties and perhaps doesn't have some of the, or at least as much of the hallucinogenic effects of ibogaine. And actually, I've cited that research mostly out of a lab of a guy named Stanley Glick. And I don't think his lab is still active. I actually don't know if he's still alive. But these publications of 18MC came out in around like 2009 to 2011. Are you worried about the coronavirus? Yeah. I talked a bit about the coronavirus early on the YouTube channel. and, sort of how to think about it, some of the biology, so what we know about it. I think there's a lot of, it's arguably a little bit too early to say things like, oh, it's just like the flu. Because, first of all, the flu does kill a lot of people every year. And we have sort of a medical infrastructure to manage the flu. You can get flu vaccines. They're not 100% effective, but they can, reduce either how badly you respond to it or how likely you are to get infected with it. We don't have anything like that for coronavirus. Like with many infectious diseases or infectious, pathogens, different demographics of people are at a much higher risk of fatality than others. And given the fact that this will be the first time that anybody that will ever be exposed to this coronavirus, you almost certainly have no useful immunity to this coronavirus. And unfortunately, it seems to be the case that among coronaviruses in particular, you sort of lose, even if you were exposed to it, you develop an immunity to it. It seems that it can, that we sort of over time lose our immunity or our immune system memory of coronaviruses. And so as a result, that's kind of frustrating. But also, coronaviruses are like, there are many coronaviruses. Most of them inhabit animals, but some of them are what cause what you would just consider to be like the common cold. But some of them are unusually fatal. And I just don't think that we have enough data that is reliable to really determine how fatal it is. But based on what we do know, it's pretty high. It's not like Ebola, but it's still higher than I would like. And so as a result, yeah, like I'm concerned. And, I'm not so concerned that I'm running out and, buying provisions and hunkering down and, sealing every like opening to the outside world of my apartment. And frankly, I already did this because whenever you have a baby, it's prudent to wash your hands whenever you get home. First thing you do, you wash your hands. And when you wash your hands, you make sure you get your thumbs and the sort of the parts in between your fingers, which is oftentimes neglected when people wash their hands. You should just do that in general. It'll reduce the likelihood that you catch any, the flu, rhinoviruses, other coronaviruses. But yeah, I'm just a little bit more fastidious about doing that particularly when I'm in public areas. And the other thing that you can do is to just, many of us touch our faces like multiple times an hour, like, 30 times an hour. And we don't really realize that we're doing it. You watch me do it whenever I, itch my nose. But if you can try to avoid touching your mouth, your nose, and your eyes with your hands, that's good practices. Also, if you happen to get sick, the sort of courteous thing is when you sneeze or cough to do it into your hand. You actually should do it into your elbow. That's the best for the people around you. So, your hands are clean. Your hands are clean. You aren't out in public. Well, but people come into our apartment and touch things. And so, yeah, it's just good practice. And not just because of the coronavirus, of this COVID-19, this new coronavirus, but for infectious, pathogens in general. I have a baby, and so she's more vulnerable to a lot of these, pathogens. And she, has gotten all of her vaccines, but she hasn't finished getting all of her vaccines. She knows I'm talking about her. Okay. Should I wash my butt after I get home while I'm out? Depends on what you're doing with your butt. Duh. Is it okay to go to the gym with this virus going around? I mean, yes, it's okay. And there aren't that many, cases in the United States already. Although, the reason I didn't want to talk about this today on YouTube, even though it is a coronavirus is having a bit of a moment, is that this news is evolving so rapidly. And really what you should be doing if you feel like you're not getting enough information or you don't know who to trust, I would look to the CDC, obviously, Centers for Disease Control and Prevention in the United States. But then also for news, if you want news on the coronavirus, there's a great news outlet that I think not a lot of people are familiar with, but does really good reporting on biomedical science called Stat News. Yeah, the baby loves Stat News. STAT News. They do great reporting, and they've been. What is that? They've been following the coronavirus story. What is she doing? Whoa. I already accept this, so I have a bottle of hand sanitizer on my bag. He's like, yeah, that's not a bad idea. So let's have a deeper conversation about ibogaine, as I own a clinic. Oh, interesting. A clinic doing Parkinson's trials. Wait, this is a different person. No, it's not. The Fenway Kid. Ibogaine for Parkinson's. I've certainly never heard of that. But yeah, I mean, there are many. I mean, I guess it wouldn't be unfair to call them clandestine clinics. Certainly, if they're in the United States, they're clandestine. So one of the things about about ibogaine that I think is responsible to acknowledge is that there have been fatalities of people who intended to be treated with ibogaine for opioid addiction, who unfortunately had seizures and passed away, which is obviously not the goal of ibogaine treatment. And because ibogaine is, first of all, so difficult to study, but also, second of all, so poorly characterized, we don't know what the neuropharmacology of ibogaine is and potential interactions with, for example, if people who are trying to stop or treat opioid addiction, if they're on methadone. It could be the case that methadone interacts negatively with ibogaine, whereas Suboxone doesn't, right? Suboxone is a combination of two opioids, one of which is an antagonist, one a partial agonist, buprenorphine and naloxone. Different pharmacology. They interact with the same receptor system, but methadone has a different pharmacological interaction with these receptors. So that's why, I hesitate to talk up, I'll give you an example, a personal example. A family friend, when they found out that I had been in a PhD program in neuroscience, before I finished, because I finished in December, but they had a family member who was suffering from addiction, had been, relapsing and, had been going to, recovery programs and would quit, but then would relapse. And the person was just, upsetting because, of course, that, relapsing kind of reinforces the kind of negative affect, negative emotional experience of recovery. And it can make it even worse. And so, they were like, listen, we'll try anything. What about ibogaine? I've been reading about ibogaine. Do you think it's for real? And, I shared everything I shared with you about, and I went a little bit more into the neuropharmacology of some really interesting effects that it has on, for example, serotonin receptor internalization. It seems to have interesting effects on nicotinic acetylcholine receptors in normalizing them or causing them to resemble what they would look like had nicotine never been ingested. But, I still had to say, I can't, I don't think it's responsible to recommend it. I don't think it's responsible for somebody in my position to recommend it to somebody else. It's a personal decision that one has to make, but I think it's important that people be aware that there are some risks involved. And I'm not accusing you of our friend here who runs a clinic. I'm not accusing you of being unscrupulous, but, so I'm certainly not. In fact, I would imagine if you are interested in talking about it, that you are rather scrupulous, but not everybody is. And there are some, there's also stories of women who went to experience ibogaine and were sexually molested, and so, it's just, you're not dealing with, your local neighborhood, pharmacist or your local, hospital. And so it doesn't mean that they're all bad apples, but there are some bad apples. And so, yeah. Ian, I was going to get my PhD in neuroscience. Then I figured out I could just ask you questions. Well, I'm glad to hear it. I'm happy to oblige. I'm on 40 milligrams of fluoxetine, so that's Prozac, 80 milligrams of Geodon, and 6 milligrams of Suboxone, naloxone daily. Any thoughts? No, I hope it's working out okay for you. I mean, if you're concerned that, that's an unusual combination of drugs or it's more medications than most people take. I mean, everybody's different and people develop. It sounds like perhaps you were addicted to an opioid at one point. So an optimal course of medications for you will be different from other people who have other psychiatric challenges and stuff like that. So yeah. Okay. Hello, Michelle. Good to see you. It's been a while. Yeah. Stat News. Check it out. It's pretty solid. I freaked out the other day when workers at Sam's had on N95 masks. Yeah. So for anybody that's not familiar, so there are different kinds of masks that are available that are used in sort of biomedical settings. Probably the one you've seen the most frequently is like a surgical mask, which is essentially like cotton, It's essentially like two cotton layers, one of which is kind of like hydrophobic. It like water doesn't stick to it very well, and then on the inside it's softer. And so the idea, this is what like physicians will typically wear in sort of general settings, particularly like surgery. But it is not like optimal. It doesn't like produce an airtight seal, and most of the time people don't even realize that you actually have to pinch it over your nose. It has like kind of like a wire, like a wire that you have to pinch around your nose. Oftentimes people just put it, and it's kind of uncomfortable to wear these masks. Let me tell you, I have to wear them when I do viral infusions, and you know, you're just like you're warm all over your weird parts of your face and stuff. There is a kind of mask called N95 that is designed to filter out even more effectively. My baby, she's very she has strong opinions. So the moment that she's not getting what she wants, she lets us know. Okay, I wore a medical mask when I was out last night, and people had a worried look on. Yeah, I mean, you know, the reality is that like those surgical masks are much more effective in preventing spread than in preventing infection. So yeah, bottom line, will they work or not? Should we buy them? So no, I wouldn't recommend it. I wouldn't recommend it, particularly because there's just no indication that we're anywhere close to that level where, you know, one needs to be concerned that like just walking outside you're going to be exposed to it. You know, you have to come into pretty close contact with people who are infected. You have to be within like 6 feet, I believe is the distance. And, you know, the likelihood that you're going to even encounter somebody who's infected is pretty low. So no, I wouldn't recommend it. Honestly, what I would recommend is that you just wash your hands. First thing you do when you get home is wash your hands. Also, if you're in like an airport, if you're in, you know, a bar or whatever, you know, particularly, you know, a bar in like a larger city that's a transit hub, just wash your hands a little bit more frequently than you would, and just be mindful. Like, don't, you know, put your fingers in your mouth. Don't, you know, rub your nose too frequently. Those kinds of things are really the way you catch this virus. Is not by just like it being out in the open and like you can breathe it in. It's if somebody has sneezed or coughed in your vicinity, and either you breathe it in directly or you like the viral particles are shed onto a surface, you touch the surface, and then you physically put it into your mucosal membranes. That's how you get it. And so, you know, wearing a surgical mask, let's say you do that. Let's say you're wearing the N95 mask. It is probably the most effective mask that you have access to. And, you know, you go out and you're very confident about not getting it because you have this protection. But then, you know, you go to a bar, somebody who happens to be infected with this novel coronavirus, COVID-19, you know, touches the handle to the bathroom. You touch the handle to the bathroom. You come back out. You're still wearing your mask. I don't know why you're at a bar wearing one of those masks. It'd be kind of difficult to drink. But and then you rub your eyes or you rub your nose. That is how you would have gotten the coronavirus, not for not because, you know, you weren't wearing a mask. Okay. While I was on the train, I was mostly wearing the mask to see what it was like. Yeah, that's fair enough. That would be an interesting social experiment. Probably not the best to do it now, but it would be interesting. Reality is gloves are your better friend. Yeah, I mean, you know, you can get, you know, nitrile gloves are probably best because some people are allergic to latex. And, you know, you can get nitrile, like I see nitrile gloves at, you know, CVS these days, you know, but again, like, you know, if you were in China or in South Korea, then yeah, I think, you know, taking some of these measures would not be over the top. But, you know, there's just not that many cases in the United States yet. Now, I should say, like, I am not an infectious disease, you know, scientist. I'm not an epidemiologist. And so what you really should be doing if you're concerned is going to the CDC or Stat News. Is that just for news, I would go to Stat News. You know, I'm sure the New York Times does great stuff too. It's just Stat News has like actual scientists on their staff. You know, go to them. Okay. So the CDC is telling everyone to stop buying up all the masks. Yeah, I mean, and there's a good reason for that. And that is that, you know, the way that this could become a problem for you is if your medical center has a bunch of people get infected, right? If like, you know, your clinicians end up getting infected because they couldn't wear a mask, then that's a much higher risk that you're going to get it. Hey, what's up, MewApp? Good to see you, man. All right, let's see. Okay. I'm a little bit behind here. Tell me about your window plants. Oh, sure. Oh, I'm so happy you asked. So they're mostly succulents. Actually, you know what? Oh, this one's pretty cool. This is a pretty cool one. It's a crassula, but it grows almost like a temple structure. It's such a weird looking alien plant. But my favorite, and it's going to be hard for me to show you this. My favorite is my lithops. You can't really see it. I don't want to tilt it too much because they're so fragile. Maybe you can sort of see it. Yeah, there you go. Can you see it? It looks sort of like a little brain, right? Oh, wait, here, this is better. But right now, it's splitting, so it's like growing. Yeah. So yeah, they're mostly succulents. I have one of the oh my god, what's it called? Whatever. Tickle plant or the sensitive plant. Obviously, I have an orchid. I have the ogre ear. Anyways, yeah, don't get me started. Show us your kid. No, you know, my wife and I decided that because I think that our daughter is probably going to be the last generation who has like any say in the matter as to whether or not they have any privacy. We figured, you know, we take pictures, of course, and stuff, and we share them directly with family members, but we don't even post anything on Facebook about her. You know, it's just that it's probably overly neurotic, and who knows if there's any benefit to it. But like, you know, if I can give her the option of having been anonymous, I feel like it's worth it. Okay, we're getting a call in. Let's see. So I think we're connected. So what's your name and where are you calling from? Oh no, it seems like there might be something wrong with the call-in system. That's unfortunate. Okay, you got married. I mean, oh yeah, thank you. Yes, I did. Thank you so much for the super heart, Sadie. I really appreciate it. Good to see you again, as always. Yeah, no kid. Let it be her choice if she wants to be anonymous. Yeah, and you know, yeah, perhaps she won't be. You know, perhaps she'll just be like, why didn't you just share it with everybody? But yeah, you know, what causes hypnagogia? Does one half of the brain sleeps while the other half is awake? That, you know, you could sort of think of it that way. It's not exactly half and half, but for anybody that's not familiar, hypnagogia or hypnagogic hallucinations are hallucinations that occur either when one is falling asleep or when one is waking up. So it's in some cases it can be associated with something called sleep paralysis. And essentially what's happening is as the brain is falling asleep, it seems like sleep ought to be one of the simplest things that you can do, right? And so, you know, you're just like losing consciousness. Like, how could that be so difficult? And actually, it's kind of this fairly delicate transfer of activity from certain circuits of neurons that promote wakefulness to certain circuits of neurons that promote, you know, sleepiness. And my baby's like right around the corner. I can see her shadow. It's so cute. Oh, she can walk now. She's like pretty good at walking now. So there is this transfer of activity. And what happens when somebody experiences hypnagogic hallucinations or sleep paralysis is that transfer is incomplete. And so, for example, when it comes to sleep paralysis, there are certain substructures of a part of the brain called the pons. So if you ever look at a brain, you know, you might see that like a brain, you know, the part of the brain stem that sort of plugs into the bigger brain, there's like this little belly right here. Like, so if this is the brain, the pons is like right here. There are some subnuclei in there that are responsible for essentially paralyzing us while we're asleep, particularly during REM sleep. You know, it's not 100% paralysis. Like, you still see some spontaneous muscular, you know, twitches and movements and stuff. But it essentially enables us to not like respond physically to our dreams. But what can happen is that as you're waking up, those pontine nuclei fail to stop inhibiting movement. And so, part of your brain is waking up, whereas part of your brain is still in a sleepful state. So that is one way to think about it. And hypnagogic hallucinations emerge from a similar kind of error in the transition from sleeping to waking. So Smarty, and do you have not so smart friends? I'm serious, Jackie. I'm no smarter than you. I mean this totally sincerely. I just happen to have the privilege of studying something that not a lot of people get to study, even have the option to study. And so I sound much more intelligent than I honestly am. There's no experience in my life has ever indicated to me that I'm any more intelligent than anybody else. Like the other day I had A Beautiful Mind playing in the background while I was doing some reading, not at full volume or anything, but. And like I think they do a good job of like John Nash was a genius and he suffered for it. Albert Einstein was a genius and he suffered for it. Like, so I am no more intelligent than any of you in here. I am like as confident as I can be about that. And yeah, I have friends in and out of science, and I think they're all quite intelligent. I found you. I forgot my old password and had to make a new account. Oh, that's awesome. The Lurker. Well, I'm glad you made your way back. Aboriginals say we have three brains, the stomach being the largest. Your thoughts? Well, we use the term the brain to refer to a very specific part of our nervous system, and that is the part within our skull, right? But our nervous system is much bigger than just the brain, and I don't know what that I assume that the Aboriginals include the brain, what we call the brain. The digestive, the stomach brain, and then I don't know what the third one would be, but it is true that we have a very like intricate and diverse nervous system that regulates our gut. It's called the enteric nervous system, and it has there's a ton of neurons that comprise it, a full panoply of neurotransmitters, a full complement of neurotransmitters. There's more serotonin that's synthesized within the enteric nervous system than within the central nervous system. And so, yeah, but like, just because, so it is a very important part of the nervous system, right? But just because there's a lot of neurons in one place doesn't mean that consciousness can emerge from it. And in fact, the enteric nervous system is so sophisticated that it can operate independently of any signaling from the central nervous system. But it does one thing very well. It does digestion, right? That's essentially what it does. It extracts nutrients. It helps to tell the brain the sort of nutrient status of the body. And so, but what it doesn't produce is consciousness. It seems to be the case, based off of all available evidence at our disposal, that to have consciousness, you have to have something like the brain. And there are different examples. There's, some would argue that there's a spectrum of consciousness, with human consciousness being at the sort of the most sophisticated, that at least of which we're aware on Earth, with then different declinations as you go further down the scale to no consciousness. So just because I could grow a big bucket of neurons, like you can do that, but there's no reason to believe that bucket of neurons would be conscious. The secret sauce is in how these neurons are connected to one another and how they're able to process information. Excuse me. Oh, the heart was the third one. That makes sense. There is a lot of nervous system tissue around the heart. But anyways, yeah. I always enjoy Scopes. It's just a great convo. Well, I appreciate it, man. It's great to see you in here again. Have you read When Breath Becomes Air? No. Is that a book? I'm not familiar with it. There is some really interesting research that's emerged fairly recently about the relationship between respiration and mood state. There's a reason that doing that actually does affect your mood, if only marginally. And there's some interesting research that suggests that a part of one of these very primitive parts of the brain, largely in the brainstem, called the parabrachial nucleus, has some signaling relationship with the limbic system, with parts of the brain that regulate mood. Parabrachial nucleus is associated with our respiratory rhythm. How can we use this information for our benefit? That's a great question. As a scientist, as a basic scientist, I'm not necessarily driven by the pursuit of useful knowledge necessarily, although I do think that in biomedical science, there is just a higher frequency that discoveries happen to be useful because, of course, we're trying to figure out ways to intervene biomedically to improve quality of life and reduce suffering. Oh, there's somebody calling in. Let's see if we can get it to work this time. Boom. Let's see. There's an adorable profile picture. Oh, no, yeah, it looks like there's something wrong with the calling system. That's too bad. I really enjoy that. That's kind of frustrating. But so like some of the more practical things can be like, like the utility of cardiovascular exercise for, cognition and staving off dementia. There's also like, for example, for me, like when I learned about the mesocortical limbic dopaminergic circuit and like how it works, and how it regulates. Okay, let's try this one more time. How it regulates attention. That did sort of change the way I studied. Okay, looks like we did connect. So vice versa. What's your name and where are you calling from?
I'm Vice from San Antonio, Texas.
Vice from San Antonio. Awesome. What's on your mind?
Since you're a brain guy, what are your thoughts on near-death experiences?
Yeah, interesting topic. So NDEs, near-death experiences, refer to, some of the most exotic, unusual experiences that a human can have, right? But I think it's really, really important as we contemplate near-death experiences to just maintain in our mind that these are not death, right? They are near death, so they are not synonymous with what happens when we die.
Could I interrupt?
Yeah, sure.
So when a heart stops beating and a doctor clinically addresses them as deceased, is that not them being dead?
Well, so different scientists and different clinicians refer to different things as technically death, right? So, for me, I think what's more relevant is if there's absolutely no neurophysiological activity whatsoever in the central nervous system, and if, some kind of biomedical device wasn't sustaining the heart, then that to me I think is like pretty much as technically close to death as you can be. But yeah, so I mean that's just sort of like a useful designation clinically, where it's like we've crossed the point of no return and there's no way to revive this person. But what I mean is that like, okay, so if somebody has been clinically determined to be dead, their heart stopped beating, and a physician said this person is dead, but then they, for whatever reason, come back to life or recover, that means that if it was death, it certainly wasn't a permanent state. And so there was something about their biology that enabled them to recover. And so it is that specific thing that distinguishes a near-death experience from a true death. But anyways, that's not even the most important part of this, right? What I think the most interesting part of near-death experiences is like the very kind of transcendent, interesting, numinous experiences that people can have during near-death experiences, and that they oftentimes involve sort of conscious experiences or like sensory experiences where people will retell an experience of them floating above their body, or seeing a light, like a source of brilliant light. And so I of course approach these experiences from the perspective of a biomedical scientist and a neuroscientist. And so here are some things that I can bring to the table. First of all, we can artificially induce the experience of being outside of your body, of like, for example, it has been produced in laboratory settings where you can feel as though you're standing behind yourself looking at your own head. You can also induce the experience of floating, of being like, above and apart from your body. Of course, you can also artificially induce the perception of light, of experiencing like auras or sparkling sort of components of your visual field. And so, far be it from me to try and describe the spiritual components of the experiences that people have during near-death experiences. But what I can tell you is that at least from the near-death experiences that I have seen, the sort of accounts that I've seen, none of them strike me as impossible for the brain to generate on its own in a completely novel state, which is a state where it is close to death, right? And so just to give you one more example. So, as the brain is being deprived of oxygen, essentially what happens, but because of the anatomy of the brain, is that certain parts of the brain begin to...
Can I stop here?
Yeah, sure.
I think where you're heading to is to like whatever religion people believe is what they'll see. So like when they die, they'll see Buddha, or if they believe in Buddha, I'm saying,
yeah.
Or if they believe in Jesus, they'll see Jesus, or if they believe in whatever, they'll see whatever. Is that what you're heading to?
Well, yeah. Well, I'm not even necessarily gonna, that's just outside of my purview, the sort of spiritual components. What I'm saying is that, just from the biomedical science, what happens as the brain is being deprived of oxygen is that certain parts of the brain shut down first. And essentially what happens is that over time, the ability for, certain parts of the brain to get oxygen is, pared down and trimmed down until it's just the bare minimum that is necessary to sustain life. And so that will inevitably be associated with a change in perception. So for example, the visual cortex is one of the furthest, it's a very big part of the brain, but it's far away, it's in the back, it's far away from, let's say, parts of the brain that regulate respiration, the parabrachial nucleus or whatever. And so as activity in the occipital lobe is going to be influenced by that deprivation of oxygen, that's going to translate to changes in your visual experience, you're seeing things that aren't there because neurons are operating under a novel.
So can I ask, if as a brain scientist, do you believe there's life after death?
Well, okay, so I used to talk about my sort of own personal beliefs early on, but then I decided I just don't think that there's much value. I understand why people wonder that.
I don't want you to please the crowd. I just want to know what your personal opinion is on.
I understand, and you know what? I've decided that I don't want to share my personal experiences or my personal beliefs just because it's not my expertise. It's not my expertise. You might as well ask anybody else what their spiritual beliefs are. But anyways, Vice, thanks for calling in. It is a really interesting topic.
Thank you.
So I appreciate it.
Your pretty awesome. Thank you for having me on.
My pleasure. Call back, I hope. All right. How do you feel about the supplement Nupept and its supposed nerve growth effects? Okay, so Nupept after this call. Let me write that down. I'm glad to see that. It looks like we're connected. What's your name and where are you calling from? Are you there?
Hello.
Hi, what's your name and where are you calling from?
I'm Claudio. I'm calling from Brazil.
Awesome. So what's on your mind, Claudio from Brazil?
Yeah, I was the one who asked before about hypnagogia. Thanks for the answer. Very clear explanation. My second question is about sleepwalking. When I was a kid, we are a large family, and me and all my siblings, we would occasionally sleepwalk. I had one sibling who was known for being the sleepwalker in the family, and my parents were concerned that she might, walk into the balcony. We used to live in a sort of a penthouse back then, and hurt herself. So I remember vividly they locking up every door and everything. And I wonder what science says about sleepwalking nowadays. How do you describe this?
Yeah, so it is actually kind of related to hypnagogic hallucinations as well as sleep paralysis. In fact, it's kind of the flip side of sleep paralysis. So as we said with sleep paralysis, as you're transitioning from a sleeping state to a waking state, certain parts of the brain do not successfully transition. And that part of the brain, those pontine nuclei, continue to sort of prevent movement signals to sufficiently escape the brain to get to your voluntary muscles. Now, the flip side of that is as you're falling asleep, the transition to a sleepful state is those pontine nuclei, those structures within the pons in the brainstem. They are supposed to paralyze us, essentially, or prevent movement. But if they do not successfully transition to a sleepful state, what happens is that the body is not paralyzed. And so, part of what happens, particularly during REM sleep, which is when we think we have most of our dreams, you have these sort of automatic patterns of activity in the brain that we oftentimes perceive as dreams. But part of that will be, like, for example, imagining that you are cooking or, doing something that you did during the previous day. And because your brainstem is not successfully preventing those movement signals from getting out from your brain, you get up and move, right? And so that's essentially what sleepwalking is. And it turns out that it is more likely to have multiple bouts of sleepwalking if you have just one bout of sleepwalking. So there seems to be some anatomical or genetic or some combination of the two cause that makes people more or less predisposed to sleepwalking. And then the last thing I'll say is that it turns out that some drugs seem to be able to induce sleepwalking, most notoriously Ambien. So the sedative hypnotics, because they have this unique pharmacology that is similar but distinct relative to benzodiazepines, it turned out that it seemed to induce sleepwalking in people who had never sleptwalked before. And so it may be the case that the same receptor system with which Ambien interacts, the GABA B receptor, may be what's pivotal in, causing either sleep paralysis or sleepwalking. But yeah, it can be quite dangerous. Oh, in fact, and there's one more thing I'll say. There is a sort of a formal condition or disorder that is recognized and diagnosed called REM behavioral disorder. And what's wild about REM behavioral disorder is if you watch videos, first of all, if you watch a video of somebody just sleepwalking, usually it's kind of clumsy and they're not very well coordinated. But in REM behavioral disorder, people look as though they're completely awake. Like there's a video that I have, I think on my podcast or something, where there's a video of a guy who's a smoker and he's getting a sleep study done. He's laying in the bed in a hospital and, they're measuring all of his brain activity and so on. He falls asleep, he gets into REM sleep, and then he begins like these very graceful movements and he looks like he's smoking a cigarette. And if you were to watch a video, you would think he was completely awake, but in fact, he's totally unconscious. But ultimately, that's what it comes down to, is that part of the brain that's responsible for shutting off movement as we fall asleep doesn't successfully do so. And as a result, people are vulnerable to getting up and walking.
Thank you. Thanks very much for that.
Yeah, interesting topics, Claudia. I appreciate you calling in.
Thanks.
Okay. Let's see. Somebody explain consciousness. Somebody please explain consciousness. Acetylcholine affects everything from heart function to muscle tone. Indeed. Although the heart, of course, is a muscle. Yeah, that's definitely true. Acetylcholine is easily one of the most important neurotransmitters. And of course, it's near and dear to my heart. It's in essentially all of my academic publications. So we are lucky to be called by a friend of mine, Othman, in Saudi Arabia. What's on your mind today, Othman?
Hey, Ian. You hear me?
Yes. Can you hear me?
Yes.
Excellent.
I can hear you.
What's on your mind?
Yeah. So my question is, lately I was involved in a topic I think you've heard of, which is anti-psychiatry movement. I need your comment on that from the perspective of neuroscience. I know it sounds like, I don't know if it sounds like flat earthers and the normal earth we believe in, but your comment on that.
Well, so
I've heard that podcast called Exploring the Mind, if you have heard of this podcast.
Exploring the mind. I have not, but I will check it out.
Yeah, they brought, I think, a psychiatrist or psychologist, and she talked about this for like almost 2 hours. It was interesting, but I need your comment on that.
Well, so I'm not familiar with this particular movement, but, I can, sympathize with people who are frustrated with the lack of sophistication in psychiatry. And that's not the fault of psychiatrists, by the way. Modern psychiatry is not that old. It's only been around for a little while. And we're fortunate to live in a time where we've graduated from, surgical interventions to treat, psychiatric conditions. But the brain is the most complicated organ in the body by far. Therefore, the mind is the most complicated thing that the body produces. And so, yeah, so it's, I can appreciate the frustration of people who are like, why can't you cure addiction? Why can't you cure depression? Right? We know that these have existed for such a long time. You can cure, or you can at least successfully treat diabetes. We can cure certain cancers. How could it be so much harder? And, the reality is we do have treatments for a lot of things that are moderately effective for a lot of people. But let's just take depression as an example. About 30% of people have no successful treatment whatsoever. And that's a large number of people. And so, I can appreciate the frustration that people experience. However, my, counter argument would be, at least we live in a time when psychiatrists are armed with some knowledge of the brain, and we're in the process of gaining more and more knowledge that's necessary to improve the competency of psychiatrists. And so long as we continue considering neuroscience a priority, we will improve psychiatry and we will have better treatments for addiction, for depression. So I mean, that's my sort of surface perspective to somebody who is against psychiatry in principle. I suppose I could keep, jabbering on, but yeah, that's my reaction.
Thank you, Ian. I have too many topics to discuss with you, but I don't want to take from your time.
Oh, listen, Othman, I appreciate you calling in. It's always a pleasure to talk to you.
Yeah. Bye-bye.
Bye. Okay. You're really going to need some quiet time after this. You should attend Quaker meetings for sure. I've never been to one. I'd love to go, but 51% or less. Please, can you give me a percentage of PTSD? Is it curable? I don't know what the percent of successful treatment of PTSD is. PTSD is a unique psychiatric condition, and there are some treatments that are like uniquely effective for PTSD that aren't necessarily effective for like depression or generalized anxiety disorder. And those treatments don't exclusively have to be, pharmacological. Like there are certain psychological approaches that are sort of uniquely useful when it comes to PTSD relative to other psychiatric conditions. So do I need a brain scan to officially diagnose PTSD, anxiety, and depression? No, definitely not. In fact, neuroimaging is not the optimal tool to diagnose psychiatric conditions because we haven't done enough neuroscience yet to recognize the distinctions between depression, anxiety, and so on. Those conditions are diagnosed by their symptoms, by people who, by psychiatrists, neuropsychiatrists, and so on, who have experience recognizing, if this is your spectrum of symptoms, then you're most similar to this large collection of people who also had a similar collection of symptoms, who responded the best to X, Y, or Z treatment. Okay, we have another caller. Oh, weird. Boom. Boom. Looks like we're getting a call from T-Bone Productions. Let's see. What's your name and where are you calling from?
Hey, Tyler from Philadelphia again.
Right on. Tyler from Fishtown. What's on your mind, man?
All right, well, just before I get to my question, pertaining to the earlier conversation of being able to visualize things.
Yeah.
For me, I didn't get the answer earlier because I was working. But, so I can visualize things, but it's kind of like, are you familiar with the photography process where you shoot through a mirror or a piece of glass at an angle and you're seeing everything through that, but you're also seeing the reflection of what is being reflected from the other angle?
Yeah.
So that's kind of how it looks to me. Like I can get a little bit of a slight image and that's about it. But it is like accurate to what I want, usually. So, to the question anyway, oh yeah, and also I can do that with music. I can kind of hear samples of sounds and then throw them together into music.
Very interesting.
Yeah, I can't play back a whole song. I mean, maybe if I lay down and really focus, I can get through one, but generally I can just get little bits. But it's almost like the experience of hearing it, but without your ears.
Interesting. Yeah, I can't do that either.
That one's pretty weird.
Yeah, that's awesome.
So question-wise, I was wondering, okay, so how can we be sure we are conscious, not dreaming, or plugged into the matrix?
Man, well, I mean, that is like one of the classic questions in neurophilosophy.
Yeah.
And, okay, like the short response is there's no way to objectively demonstrate, at least I've never seen a convincing argument of how to objectively demonstrate that you are conscious and not being, not just a byproduct of a simulation or, not plugged into the matrix. For my perspective, I take the sort of the pragmatist approach, which is if you have to have some sort of basic assumptions about consciousness to move forward. And for me, one of the basic assumptions is I am conscious, because if you are not conscious, then you can't really move forward in understanding consciousness or understanding, human psychology or how we interact with one another. But there are certain things, of course, where are the laws consistent? Are there any examples of the laws breaking down, the laws of physics breaking down under odd, circumstances? There are those kinds of cognitive tools, but yeah, there's no Jeffrey Nagel in, the 1970s came out with the algorithm that demonstrates that we're conscious. At least I've never seen that kind of an argument before.
Okay, all right. Do you have any interesting takes on say the Truman syndrome?
Yeah, that's a super interesting one, right? And so what Tyler's referring to is, it's a syndrome that's named after a movie called The Truman Show, which is it's a pretty cool movie with Jim Carrey, and he essentially discovers that he is the byproduct, or he is the main character in a reality TV show where essentially he's living in a kind of fabricated environment neighborhood where everybody else is in on the show, like they're all actors essentially, and everything about his experience is fabricated essentially to produce this TV show. So, I mean, I think it's interesting on several different levels, but I think it is sort of like a very similar manifestation to like paranoid schizophrenia, where folks with this a manifestation of schizophrenia are predisposed to making connections in pattern seeking that are inappropriately connected. And actually, I brought it up earlier, but A Beautiful Mind, I think, does a pretty good job of demonstrating like the paranoia that can come with schizophrenia, where, he sees a bunch of people pull up to a building where he's teaching, and everybody's wearing a black coat. They're driving a black car. And, because he's paranoid, he assumes that these are like FBI agents or something. And of course he was wrong. And it just turns out that a lot of people wear black coats, and so, yeah, I just think that, that the Truman Show, like, almost certainly kind of planted a seed in the minds of people who are like vulnerable to that level of paranoia. But have you experienced anything like that?
No, I can't. I've had some weird experiences, but I wouldn't say anything along those lines. I think maybe one of the weirdest things I experienced is one of those, it wasn't an out-of-body experience, it was an experience of levitation, where I woke up one night and I could have sworn I was about 3 or 4 feet off the top of my bed and fell into it.
My baby has strong opinions about that experience. Perhaps she's experiencing it right now. Yeah, I mean, I've had some weird experiences like that too. So like, as I was falling asleep one time, I had my eyes closed, and I don't know why she's so vocal right now, but maybe she's just trying to get in on the conversation. But anyway, so I'm sitting there, and excuse me if you can't hear me, but I'm lying there, my eyes are closed, and I feel like I can see my entire room. This was when I was in college. I feel like I could see everything in my room, and I can even like turn my head and everything, but my eyes are definitely closed. And, I was clearly experiencing some memory of my room, and I was having this visual experience, but it was essentially a hallucination. What was the other thing? Oh yeah, another thing that's interesting about the Truman syndrome is if somebody is dosed with a high dose of amphetamine or cocaine, you can induce that kind of paranoia. And like one of the classic symptoms of somebody who's like been binging on amphetamine or cocaine is they're like constantly looking out their window. They're very paranoid that they're being pursued. And that is just an amplification of activity that enables us to be pattern seeking. And then there is like this role played by the volume of activity in parts of the brain like the amygdala, which is detecting threat. And so you have this elevation of pattern seeking, and you have this elevation of threat detection, and as a result you get this kind of paranoia that can be induced pharmacologically, or it can be the byproduct of paranoid schizophrenia.
I guess they could make a Truman show too then, because then they can just convince Jim Carrey that he went through that, and what he imagined breaking out, but it wasn't real.
Yeah, exactly. Yeah, totally. I think, it's probably, not a stretch to suggest that we all have some predisposition to that kind of paranoid pattern seeking activity. It just so happens that some people are more vulnerable to it than others. And so, yeah. But anyways, yeah, awesome topics as always, Tyler. Thanks for calling in, man.
Thank you. Have a good one.
You too. All right. I agree with your mini-me. She has a good argument. Yeah, she has gotten very vocal lately. Hey Doc, how do I make a call on Periscope? This is new to me. You should see a little symbol down there on the bottom corner. with two faces. That's how you do it. Press that button. Okay, is PTSD projected via the brain, or is it from the trauma of your past experiences reoccurring? Well, I would submit to you that those are largely one and the same. PTSD is generated within the brain, for sure. And it is a traumatic experience that provides for that psychiatric condition. You don't necessarily have to re-experience whatever traumatized you. It is just that the experience was so traumatic, so emotionally arousing, aversive, that we evolved to learn from our experiences, and part of what we use to learn from our experiences is mood and emotion. And if an experience is so severely aversive that it's traumatizing, then we evolved such that you should essentially always be under the operating principle that everything you do is to avoid that past traumatic experience. And so that induces something like a PTSD. But anyways, I should probably call it a night. So thank you all for hanging out. It was my pleasure. I have a podcast called Wired to be Weird, where I talk about a lot of these topics that came up today. I have a YouTube channel, and I'm getting close to making it easier now to find it, but you can type in like Ian Anthropoid Brain. And today I talked about a case report, a publication of a woman who took about 550 times the normal dose of LSD. It's an interesting, and there's some interesting findings from that case report. I also talked about Tusco the elephant, who was dosed with a massive overdose of LSD, and I talked a little bit about that story. And I talked about Trey Parker and Matt Stone, the creators of South Park, taking LSD before the Oscars, in which they were nominated for Blame Canada. And I also have a Patreon, patreon.com/anthropoid. If you're in a position to be able to support me in any of these endeavors, I will deeply appreciate it. Patreon.com/anthropoid. Otherwise, I will, at a minimum, see you same time, same place next week. And until then, have a great week. See you guys. All right, YouTube. Thanks for watching, everybody. I know that one went kind of long, didn't it? Yeah, geez. Okay. Thanks for watching, everybody. See you later.